So it starts off nice and gentle, right? Let's not jump to the answer. Let's get some methods for how to solve these. What might be the first line you write after question 1? After the question. Someone? Anyone? Any takers? What are we looking for? Pair of numbers, right? What are the pair of numbers going to do? We want them to add to 4 and multiply to 3, right? And so clearly the example we're thinking of is 1 and 3. 1 and 3. So I can write down this factorization. And from there, I can simply read the solutions. Remembering if you've got, come in, grab some in, that's okay. If you've got a pair of numbers, this one and they multiply to give 0, one of them has to be 0, right? So if this one's 0, then x equals -1. Or alternatively, if this one's 0, then it's -3. No props, okay? Number 2, ever so slightly more difficult because that minus sign in there means you need to take that into account, that pair of minus signs. So we want a pair of numbers that adds to -1 and multiplies to -30. Who can think of it? Yeah, Candice.
5 and -6.
Okay, very good. I want 5 and -6. You can think immediately when you see 30, you can think 5, 6, right? But which one's negative? Then you go to here and you're like, I want to add them up and be -1. So you want 6 to be negative, right? Because it's bigger. So this is my factorization, okay? And that gives me my 2 solutions. Okay? By the way, not that it matters a huge amount, it'll be right one way or the other. But if you want to try and get these in order, it's actually nicer to have them in ascending order, like this. So you have your smallest numbers first, but that's not a big deal. Okay, number 3 starts to get really involved because it's, remembering those first 2, we call them monic quadratics because there's not monic, which is more tricky, but still doable, okay? What am I going to do? I still want a pair of numbers, right? What pair of numbers am I after? What does a pair of numbers do? Someone else. Someone hasn't mentioned anything yet. No, I'm very glad for any answers offered. Yeah, Dinesh.
Is that the one where like it's 11 and then 12 by 2?
Yeah. So the pair of numbers that adds to -11 but multiplies not to 2 but to 24. Okay? So adds to -11, multiplies to 4. I'm thinking I want -3 and negative, right? Because you add -3, -8, that'll give you the -11. Okay? Is that good? So what do I do with this -3 and -8? Like where do I put those numbers?
Both negative.
Say it again?
Both negative.
Both are negative. So does that cause me any problems?
No.
That's going to be okay.
You, multiply them with the 24.
That's good. Okay, so that's what gives me the positive 24, right? Now in 1 and 2, because they're monic, I can take that pair of numbers and I can chuck them straight into this factorized form, right? But when it's not monic, yeah, I need to do something slightly different. The -3 and -8, I'm going to break apart this middle term into -3x and -8x. So I'm going to write that down. 12x squared. Now, let's see here. I can write -3x first, or I can write -8x first. Which do you think would be better? Why don't we just try it? Why don't we just try it? Because the great thing about this is, if we do it wrong, it's no big deal, right? We'll just try again, okay? So if I've written down -3 first, and that equals 0, okay? Let's see what happens when I pair it up. What factor can I take out of the first pair? I can take 3x out, right? And that leaves you with here 4x and -1. Does it look promising? It does look promising, doesn't it? Okay, I could have done the -8x with the 12x squared and then taken out 4x instead, but then I'm going to get something in here which is not going to match up with my next one. So no big deal. You just stop and try again, okay? Here, the factor I'm going to take out is... I want -2. I don't just want 2. I want -2 because this number out here, the constant, just the numeral, I want it to be negative, right? So that's going to give me 4x -1, just like I was expecting. Now I've got my pairs, and so I can factorize. Okay, fantastic. And we can, again, read off the numbers here. The solution to that left-hand part, if I make that left part 0, I'm going to have 2/3. Very good. Or a quarter in there, right? You're starting to get the hang of it. Great, let's move on to 4. Now, I'm going to show you a trick on this one because the numbers end up being a bit bigger when you have to work with them and it becomes a bit harder to work out these factors, right? So I want a pair of numbers that adds to 9 and multiplies to negative, right? Yeah. Now, but negative 70, I don't know the factors of 70 like this, right? So I can think some of them are obvious, right? But I want to make sure that I get all of them so I know which one's going to be the useful one, okay? So here's my, my really handy trick. Get your calculator out, okay? Grab your calculator out. And your calculator's a button through year 10, 11, 12. My calculator didn't have, so I recently discovered this existed, okay? 70 is the number that we want to factorize. We want to work out, okay, what numbers can go into this that multiply. That's the whole point of us, these numbers. So take your calculator and punch 70 in the display and then hit equals, right? So that 70 is there. You've pressed C, you hit equals, now it's bottom right, okay? Now the button I'm after, because I want factors, right? I want to factorize this thing. You might be able to see it just above the degrees, minutes, seconds button. Do you see that? In yellow, it says fact, which is short for factor, okay? So since it's yellow, you press shift, fact. And then it tells you that, okay? So 70 is equal to 2 times 5 times 7. Now, I want you to think all the way back to year 7, right? What this is, and maybe you want to just write this down on the side, because it's so useful. What your calculator has just handed you is called the prime factorization. Do you guys not have that button on there?
No, that's the newer version.
Okay, right. Now, if you don't have it, it's no big deal. You can still do this process without this, just like I would, okay, with, you know, back in the days when this calculator didn't exist. But for those of you, and a lot of you do, because this is the one that we sell, let me show you how this is useful, what I'm going to do with this, okay? So, first thing, I already see 2 times 5 times 7. 2, 5, and 7, they're all factors of 70. So they're all candidates. They could be like one or both of the numbers that I'm going to use to pair up, okay? But those aren't the only factors. There are more than 3 factors, right? For instance, I mean, you know, all numbers share at least one factor in common, namely 1, right? That's a factor. But also every combination of those numbers is also a factor, right? So for example, we know that this is a multiple of 10, right? Like 7 times 10. And I get 10 from 2 times 5, right? So 10 is also a factor. I can see there's a 5 times 7 in there, so that's 35. 35 is also a factor. There's one more. Can you see what other combination could I use? I could go 2 by 7, right? 2 by 7, which is 14. 14 is also a factor, okay? Now, I don't know about you, some of them are really obvious to me. Like, okay, it's an even number, that's obvious. It's a multiple of 10, that's obvious. 14. Not so obvious, right? I mean, you can work it out, but it doesn't just jump out at me, okay? Now, that's particularly useful because when you look again, come back to the original question, I want a pair of numbers that adds to 9 and it multiplies to negative 70, okay? Which is different by a difference of 9, right? Well, let's see here. 7 times 10, are they off by 9? No. 1 by 9? No, they're off by, you know, a much bigger number. What else have we got here? 2 by 35. Are they off by 9? It's not happening, right? Which pair do I want? I want that non-obvious one. Okay? So 14 and 5 are my actual numbers. I want one of them. It's when I add them together, I want a positive number. So therefore, if I want 70, I'm going 5. So 5 times, that will give me negative 70. Okay? So now I've got my pair of numbers. Now I know, just like this line, how to break apart that plus 9x. So question 4, what have I got? I've got a 2x squared out the front. This one's an easy one to choose. Which one am I going to write first? It's got to be the 14, right? 14x minus 5x minus 35. Are you okay with that? You see how I use those numbers again? Sometimes when you're solving a maths problem, the problem is so large that you solve one part of it and then you forget why you were solving that part. Okay, we've got that pair of numbers. Here's where we're putting it, okay? Can we pair these up now? What's the common factor? 2x, very good. When you take that out, that leaves you with x plus 7. Good, okay. What's the common factor here? Minus 5, right? And that, again, leaves you with x plus 7, which checks out, okay? So I'm going to factor now. And in some senses, like that was really the hard part, right? I think I've done the hard part. But I might as well finish off the question, solve it. I'm going to read two answers off this. Off the left-hand side, what number am I going to stick in there to get 0? 5 on 2, 2.5. And this one's really easy, it's just -7, right? Happy times. I guess I would usually write that first, but no big deal, okay? So, if you have that factorize button, it's handy, but it's not necessary. It's not necessary. I think that, like I said, 2 is easy to see, 10 is easy to see. If 2 and 10 are both factors, then 5 also has to be a factor, right? So you can use your calculator, be like, what's 70 divided by 5? And it'll tell you 14.